Okay, so what I want to do is screen here. Okay, what I want to do is I've got some alternative materials to cover our first three, or I guess our topic areas, and talk about the introduction to databases, which I want to introduce. I'm going to do three. Going to try to make them pretty focused recordings. So this is chapter one, chapter two, chapter three. There's a couple books we had looked at in uh, the fall semester, and this was one that we had taken into consideration, and we actually leveraged the content of this, in conjunction with the stuff we already have out there. So, okay, so what I'm going to do is I'm going to kind of walk through kind of this is once again this is the introduction, kind of the introductory part, kind of giving an overview of databases and the some of the basic concepts. So, basically, we want a couple of things we're going to talk about. We've heard it on the other and on the other videos. The difference between data and information. What's a database? The importance of database design. Um, how did we get there in terms of like modern databases? The importance of modern databases and how did it come to be? Also things around some of the things that databases do to improve upon things like file systems. Also talk about the major components of a database system as well as what we mean when we talk about a DBMS, database management system. Okay, so to start, as we're looking at this, we start off with the idea of what is data versus what is information. All right, so we hear this term used a lot. I mean, your data, big data. Um, so there's a, what we're talking about in this context right here within computers. So this is going to be digital data. All right, which has really been what we've seen in terms of massive growth. But data in and of itself is really just raw facts. All right, the recordings, signals of of things, activities, not really been processed. So it's basically a collection of stuff. But what it is it is the building blocks. It's the foundation of what we use to generate information. All right. And the techniques we use around this is what we call data management. So it's the generation, storage, and retrieval of data. All right. And then as we do this, what we do is we end up creating information. So data is used to create information. So we process raw data, we add context to it, and structure to it, and then that becomes really the kind of the information, things we can make decisions off of. Okay, that's really what this whole idea of taking, and we've been doing this whole data to information thing in the computer business for as long as we've had computers. All right, that's basically what computers do, and computers do well. All right, so we've been doing this for a long, long, long time. So the main thing to remember about this is that the fact that you've got one feeds the other. All right. And then above that, actually, as we say right here, if we take collections of information, ultimately that can move up into knowledge. The other thing that as we look at this, just one quick aside here, when we think about the volumes, so part of this transformation of data to information is a reduction. All right. So we could have more data, and we process it, and at the end we have a smaller amount of information. All right, so it's because we'll be consolidating, we'll be selecting, we will summarize, we'll do a whole bunch of stuff and within on the information side. So let's talk about what do we mean by a database. So what a database is basically it's a computer structure that stores a collection of data with a particular defined with a defined structure to it. All right. So what it is we have things like the end user data. All right, so we take kind of raw data, but then what we do is we define it. We go through and we analyze it, and we define it using what we call metadata. So what metadata is basically a definition of what something looks like. So the third column in this particular record is Social Security number. All right, that's something that gets applied to. It's not in the raw data, but as we apply metadata to raw data, then we get, um, we add the structure to it. All right. So basically, and that's really what a database, what a database is. It's a defined structure of data that we can process and extract information from. All right. There's a term called DBMS, or database management system. All right. Whereas the database is a file. All right, the database management system is actually software. So it's actually a program or a bunch of programs. And what it does is it's the thing, it sits between us and the database and really serves as the translator, on our behalf of everything, of getting data out of the database. So it controls access to data. It will, it's our, the basically the intermediary. All right, and what it really enables, it also enables the data to be, it manages it in such a fashion so we can share the data and then present back an integrated view of what it looks like. Right. We'll take requests. It can take requests. DBMS will take a request to to search for information, search it on our behalf, and then return the requests. All right. And really what it does is it hides the internal complexity of the database from us as people. So if we look at kind of a picture here, what we have is DBMS is in the middle, database management system, which is the software. On the back end, we have the database, which with metadata and then data organized in the different tables. We'll talk about tables, but customers, invoices, and products. All right. So what happens is this is us end users logging onto a computer or something. Submitting requests to the DBMS. I'm looking for this information. Have it go out, search the information, retrieve it, and then send it back to us. So the advantages. There's if you look at right now, virtually every organization has multiple databases. Every website has most modern websites are based on at the core having a relational database or a database behind it, and there's a reason for that. So there's a lot of things that databases let us do. So it allows us to integrate data, and it also enables us to organize data and be able to keep it, I guess, clean. We don't want to have inconsistencies. If you start, and we'll talk about this in just in a little bit about how as you move data around, data inconsistency. What we mean is different versions of the same data in different places. All right. So what we want to do is we want to minimize that. We want to eliminate that. All right. It increases end user productivity, improves our ability to share data, to secure data, to access data, and ultimately to make decisions, make good decisions. Ultimately, that's what we're using this stuff for, is to be able to make decisions. Data quality, which is the attributes of the data. What you want to have is as high quality of data as you have, because obviously the better the quality of the data, the more reliable, the more reliable we can make decisions, or what we can do in terms of decision making. So we measure the quality by the accuracy, the validity, and the timeliness of the data. So there's a bunch of different types of databases. You've got some databases that will sit on your desktop. So if you use Microsoft Office on Windows, there's you see Microsoft Access. You used to see this. There was a big years ago. There was actually a number of these things out there. They pretty much have, for the most part, most single user databases they're kind of, there's uses for them, but it's not necessarily something everybody uses. All right, so we're going to be using MySQL, which is a single user database. Most databases, and we kind of fall into the category where we say enterprise databases. All right, so it supports many users across many departments, and the idea is it gives us a large, the ability to store. And when we talk about large, many users, many departments, large amounts of data, We're talking about millions upon millions of rows of data or records of data, right? And the ability to process that and be able to get answers, and more importantly, getting answers that are correct. Because ultimately, our database, the most important thing we want to get out of a database is not just answers, but correct answers. A couple different ways you can see this stuff. A lot of organizations are, in large part, you see a lot of centralized. So you have one database that sits in one location and everybody will access it. You also see, some situations, some scenarios with distributed databases. What we're seeing now is more of cloud databases, or people deploying databases in a cloud. So you don't, instead of having it on a computer running inside of your data center, is to put it in the cloud. So we're seeing a definite trend over the past couple of years, is that's the direction things are moving. You have, kind of a couple different ways, a couple different types of general purposes, really, your basic, what you get out of the box. Those can be adapted to create a discipline specific, focus on specific function areas, or what we call an operational database, which most operations, usually it's a general purpose database that has been adapted to fit particular circumstances. There's also a different categorization. As we look at these things, you can use it. You can use a database to maintain a particular, store operational records, but you can also use it to analyze data. All right. So what will happen is, if you think about Amazon, Amazon is generating, is processing, millions of orders a day. All right. So all that information is being captured and stored in the database. All right. Now, if you want to go back and try to figure out, well, what's happening with that, what's going on with that, what you'll do is you'll take that information. You won't touch you won't necessarily work on the data that's in the operational database, but what you'll do is you'll create another database, an analytical database, and then you can analyze that, create what we call here a data warehouse. We're going to use processing tool, we call OLAP, or online analytical processing. So it's really a set of tools. So it's actually a whole different category of databases, but it's an important piece of what's out there. And then business intelligence is kind of that creation, the kind of the creation of information from data to support our data, our decision making. A couple different ways of data for the most part. It's structured data, formatting. There are areas of unstructured data, semi-structured data. XML is actually a markup language similar to what we see on web pages, where you can take a data structure and represent it in that. It has particular uses. But for the most part, when we look at the databases and the databases we're going to be working with a structured data model. So the one thing about databases that we have to really understand is that you have to design the database. The expectation is that in order to have this thing give you the correct answers when you ask the questions, it has to be designed in a specific fashion. Right? So you have to create a database. Have to do a well-designed database. So you want to be able to facilitate, the accessing of data, and make sure you can get accurate data accurate and valuable information coming out. Challenge with databases are you don't get that out of the box. All right, and if you have a poorly designed database, all sorts of things can happen. Most of them not good. So the evolution of this stuff really comes from if you go pre-computers, everything was manual. Everybody was doing their own processing using paper. And then what happened was when the first generation of computers came in, what happens, a lot of those paper processes, stuff we used to do with paper, we translated the paper into digital data and was processing and processed. So we did, and that was very successful for a long period of time. What's happened over just the past 40 years is the types of computing and how we access data and how we work with data with end user tools and productivity tools and Excel and spreadsheets and all sorts of fun stuff like that. That's actually has changed a bit in terms of how we interact with computers and how we what we can do and with them. But the bottom line is it's still this whole basic evolution of from manual files to computerized files to databases is still out there, still in effect. So some basic terms, you want to kind of take a look at these. When we talk about data, we say there's raw facts. Raw facts being telephone numbers, birth dates, customer names, year-to-date sales. The idea is what you do is we organize this in such a data is organized in a fashion so it makes sense. So you do is you take data and you organize it by fields. So a field is defined as a character or group of characters, which has a specific meaning. So a field that contains a telephone number, every record, that field, if the third field is a telephone number, that third field for every record that's in the database will have a telephone number. If we take collections of fields, string them together, we create what we call a record. All right, so we define it here: logically connected set of one or more fields, describes a person, place, or thing. All right, and it's one record per thing. All right, so an order. So if I have a sales order on Amazon, there is one record for that sales order. I can create multiple records, of a different sales order. If I buy something every day, I'll create a different record, but that'll be a different sale. And then when we collect all of this stuff together, it goes into what we call a file or a table. We'll be talking more about this as we go. So this is kind of a simplified file systems where people are sharing files. This could be either like spreadsheets, or it could be a actually physical paper moving from place to place. The problem was, and it worked. The thing about you don't necessarily need a computer to run a business. People ran businesses a long time before we had computers. Now what happens is there's a lot of things that you run into. So things like it's not, when you do it manually, it takes a while to set things up. You don't get quick answers. You're always checking. So there's a lot of stuff that goes in with the file system processing. All right. And there's another kind of an interest. This is kind of a sideline, but there's a thing where what will happen is in these file systems, if you change a record, so say for example you want to add a field to a record, what happens is there's a structure, what we call structural dependency. So there's the third field is social security number. Okay, if I want to add something else and put it in that third position, so it's not social security number, I have to go back and touch all of the programs that use that. So you have to rewrite things. All right. So the idea is within files you have a structural dependence. In databases are structurally independent. So we can do all sorts of stuff to data on the back end and have no impact whatsoever on the application on the front end. As we say, data access changes when characteristics change. The idea is that a database, the structure of it is a logical database we work with, and then we will create a physical storage. So by separating that, we have a lot more flexibility to work with stuff without impacting users, without impacting operations. The other thing you run into is redundancy of data. So we have a lot of replication of data, or the same data being copied and being stored in different places in different fashions, and creating different distributed data all over the place. So the idea is when you have situations like that, the probability you're going to have duplicates or incorrect data grows. All right. So the implications, and there's a number of implications, but poor security, inconsistency, data entry errors, what we call data anomalies, basically, or problems that will occur because you've got redundant data stored, or stored in a table. All right, so there's a couple things you can see with these anomalies, and we'll talk more about anomalies downstream. But you have them when you're updating data, when you're loading data, and when you're deleting it. All right. So what this means is that databases, one of the big things, the big characteristics of databases are there are rules. All right, and what happens is we define a structure. Logically related data is stored in a single logical database repository. So that's a design. That all has to be designed. All right, databases eliminate a lot of the problems we've seen historically with traditional file systems. It manages, the DBMS does a lot of this stuff. It's baked into it. Challenge is, though, it means it's a very complicated, sophisticated program. All right, so it's not, it requires, a lot of effort to make sure that things are you've got the right, you're making the right decisions, you design these things the right way. And we'll kind of show you how this looks as we go. So this is kind of an example of, database. This is your traditional file systems, applications. There's the personnel department has an application that for their employees, and all that data is maintained here. Sales department has an application for its sales, which will have this information here. And accounting will have its own. In a database system, all of this stuff is maintained in one system, one set of tables. All right. The database management system manages the access to it, tracks all of this, and controls access to it. So we can have multiple people can share, this shared storage, or can access the same storage and not affect each other. The way this is done is within the database itself. So the database management system handles all this stuff. It has logic within it that it can control it. So from each of these people's perspective, they have complete access to this. The reality is you could have, all these people could be going against the same record. And what this will do is this will sort out, the database management system is smart enough to sort out, well, who gets it first, who gets it second, who gets it third, who gets it fourth, and so on and so forth. So that's a huge part of, there's a huge part of, of the capabilities of a database management system is actually behind the scenes. All right. And this is kind of a big picture of the, what this thing looks like. So you've got of the people. So we've got, end users, people who are using it, but we got programmers and analysts who develop applications. On the database side, we have a designer, we'll have an administrator, we'll have somebody who runs the systems administrator. So it gives you an idea of kind of the number, kind of the types of people who need to run this stuff. All right, real quick, run through some of the functions of the DBMS. So what it has within it, it has what it calls a database data dictionary. So what it does is it just stores all the definition of the data elements and all the different relationships. There's a data storage management, which optimizes accessing the data that's in the physical storage and returning it as in an efficient fashion. We've got data transformation presentation. Basically, what it will do is it will translate the logical to the physical and the physical back to the logical. Right? And then finally, last but certainly not least, security. It manages user security and data privacy. Shared resource. We can be managed down to what records you can see, what files, what fields. Multi-user access control, which we had talked about. Also, we'll have built backup and recovery. So the idea is you create these systems, they become very valuable because all of the key information in the organization is in there. So the idea is it has built-in capability to both back up the data and then bring it back from the backup in case there was an issue. And then also data integrity management, minimizes redundancy, maximizes consistency. Now, how we actually talk to them, we'll talk more about this, but this is just kind of an introduction. There's a language that we use that lets us talk to a database. All right, so the terminology we use is a query. So the language we use is something called SQL, Structured Query Language. It's a de facto query language and access method that's supported by basically most of the major DBMSs, for the most part. Not 100% guaranteed everything works the same way across everybody, but because each vendor, each DBMS is written by a different vendor and they kind of do their own thing. But for the most part, the SQL languages that we use to access the database will translate from one system to another. So if you write something to run against one database, you get a pretty good chance of having it work against another one, so long as you get things are consistent. In data communication interfaces, the idea of being able to multiple environments, multiple networking environments. The disadvantages, so, as we talked about all this capability, it comes at a cost, all right? So the actual, these things are sophisticated. It takes people. It takes people to manage them. It takes, staying on top of it, making sure that the data, the integrity of the data maintains. That's when we talk about maintaining currency, making sure that the data stays correct. The question of vendor dependence, what happens is, there's different vendors that are out there. So we're using MySQL, which is actually made by Oracle. Oracle makes another database. IBM makes a database called DB2. Microsoft makes a database called SQL Server. What happens is each vendor will add its own capabilities to it. And then what happens is if you use that, if you use something that's in one database but not in the other ones, then you're going to have to adapt that if you buy another, if you try to move to another database, which actually tends to lock you in. And the other thing you've got, constant upgrading and patching, and which is part of the overall costs. And then if you wanted to grow up and become, work in the database fields, here's kind of a summary of some of the major job opportunities, career opportunities within, with databases. So developers, designers, administrators, architects, consultants. A lot of stuff. It's been a big part of the computer industry for, a good long while. It's going to be around, be different fashions, but it's a pretty big part of what we are working with. All right, so that's it for this particular recording, and what I'm going to do is I have a couple other ones I'm going to be putting out there as well. I'll talk to you in a minute.